Greetings and welcome to the introduction to astronomy. In this lecture, we are going to talk about the structures, the interior structures and the magnetic fields of the outer planets. Now, as you may guess, it is harder to determine what the interiors of these planets are like, since there is no way to explore them by the similar means that we used on other planets. So first of all, what do we know about these planets? Well, let's review. They're all far from the sun. They're large, both in size and mass. They have low density. They rotate quickly. They have a large number of moons, which we will look at in future lectures. And they also have a ring system that we will look at in future lectures. Here we see only Saturn with its rings, but actually each of these has its own set of rings. When we look at the giant planets, we can actually subdivide them in a way much as we did with the terrestrial planets. We had the cratered worlds of Mercury, and we threw our moon in there, even though it's not a planet. And then we had Venus and Mars, which were more Earth-like. Well, here we have again two types of Jovian planets. We have Jupiter and Saturn, which are primarily gaseous and liquid hydrogen. So you see their structures here. They look roughly the same. The only difference being the size. They have molecular hydrogen and metallic hydrogen in their cores. Whereas Uranus and Neptune, on the other hand, are icy. They have a core of rock and ice and a mantle, which is water, ammonia and methane. You'll see that they're missing a lot of the hydrogen here, even though they're made up primarily of hydrogen as well. That's their atmosphere. But they do not have the metallic hydrogen that we'll see will be very important for looking at their magnetic fields. Now, again, let's look at these in a different type of cutaway that we can see these. And we see that Jupiter again has that molecular hydrogen, which is its atmosphere on the outer sections. And that is the same for all four planets. The difference between the two is, of course, this metallic hydrogen here in Jupiter and here in Saturn. So there's a lot more of it in Jupiter. There's still some in Saturn, but we do not see that in either Uranus or Neptune. What do we mean by metallic hydrogen? Hydrogen isn't a metal, but what happens is if you compress hydrogen under high enough densities, it will behave like a metal, which means that instead of the electrons being bound to an individual hydrogen atom, they will flow between them and behave much like electrons do in a metal, where the outer electrons flow between electrons and can move conducting currents. So, and here again we see with Uranus and Neptune, same type of structure. The only difference we're missing this metallic hydrogen, and we'll see where that comes in shortly. Now, when we look at them again, here's Jupiter with its rocky core, liquid metallic hydrogen and its liquid hydrogen layer. So you do have a rocky core here. However, there's no way to get to it. See how that's only about 7,000 kilometers, whereas the surface is 71,000 kilometers, 10 times further away. So the densities get so dense even within the molecular hydrogen layer that nothing can make it through down to the rocky and icy materials at the core. However, we do see that they have differentiated much like the inner planets, the denser materials at the core, the less dense materials outward. Saturn again is very similar, except that it is less metallic hydrogen. Now, how about the outer two? Let's look at them in a cutaway like this. And we see that they do have that rocky core. Again, nothing we could ever reach. There is far too much material and too much density and pressure to make it down close to that. An icy mantle, icy material, and the gaseous atmosphere. And again, that is what we see when we look at any of these objects. Now, we also note that these have internal heat sources. In fact, what that means is that they give off more energy than they receive from the sun. Now, typically you'd expect that a planet couldn't give off more energy than it's receiving from the sun. Where does this extra energy come from? Well, there are a couple things that could cause this. It could be energy left over from the formation. When the planet forms, the material falls into it, having kinetic energy, and as that material moves into the planet, it eventually stops, and that kinetic energy is converted to energy of heat, which is trapped in the planet. And that can slowly leak out as it's trapped deep within the planet and shielded from just directly escaping into space. You can also have energy from differentiation, again, conversion of energies into a heat energy that then slowly comes out. So one of the big questions here is that Neptune, as well as Jupiter and Saturn, have a source of internal energy, but Uranus does not appear to have this. Why? Why is a good question, and we really do not know the answer to this yet. So again, remember how this has been studied. Uranus has been studied directly only by the Voyager 2 probe that traveled out there back in 1986 and has not been studied except at a distance since that time. Now, the other thing I said we'd look at was the magnetic fields of these. Magnetic fields exist on all of the planets and to differing effects. Jupiter has the strongest magnetic field because of that large amount of liquid metallic hydrogen. Now remember, when do we get a magnetic field? We had it on Earth because we had a molten outer core that had trapped electrical currents and generated a magnetic field by its rotation. We said that things like Mars and Venus had solid metal cores and therefore did not give off any magnetic fields, so did not generate currents, but that Mercury had to have at least a partially magnetic core because we did see a partially liquid core because it has a magnetic field. So we do see that with them, but Jupiter is by far the strongest because of that metallic hydrogen. Hydrogen compressed so much that it behaves like a metal. Jupiter also has aurora, and we see an image of that here. Aurora on the Earth caused by charged particles from the sun funneled along those magnetic field lines. Well, Jupiter also has a very strong magnetic field, and that pushes away charged particles from the solar wind, and they hit Jupiter near its north magnetic pole, and they cause it to glow as well. So we see the aurora really on any planet with a magnetic field and an atmosphere. So why haven't we seen them before? Well, the only other planet with a magnetic field we've looked at was Mercury, and it does not have an atmosphere. The planets that did have an atmosphere, Venus and Mars, did not have magnetic fields to give aurora. Now we can also look at Saturn. Saturn has a weaker magnetic field than Jupiter, but does have aurora as well. So here we can see the aurora on Saturn as well there on the pole, up near the pole. If it has a magnetic field and it has an atmosphere, is going to have an aurora. Now the other two planets we want to look at are Uranus and Neptune. They're a little bit different. They have magnetic fields, but they seem to come from a different source. Remember, they do not have the metallic hydrogen that we see with the larger planets. We also note that they are offset from the center. Most of the magnetic fields that we look at in the solar system are as though there is a giant magnet at the center creating this. We know that's not the case, but they're all centered on the center of the planet. However, with Uranus and Neptune, they are offset by a significant amount. And here we see that by 1/3 of the radius, the central point of the magnetic field is offset from the planet's center. Now, maybe with Uranus that makes sense because Uranus also has a very interesting tilt. The sun off in this direction. Uranus's south pole is pointing in the general direction of the sun. So instead of being tilted a little bit like Earth's 23.5 degrees, it's tilted at over 90 degrees. And then there's still a 60-degree angle between the pole and the magnetic field. So there's something very interesting going on with these. Unless that slushy mixture of ices that makes up the mantle has some way of generating a magnetic field, we'd say that this is something that we do not completely understand at this point. But we note again that in both cases they're offset from the center, and they are not even aligned with rotation, and they're not close. Yes, Earth's is also shifted by a little bit, but not by 60 degrees. Would be a tremendous difference between the two. So let's go ahead and finish up with our summary. And what we've looked at here is the Jovian planets, and we divided them into the liquid and gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune. We looked at the fact that most of these Jovian planets have some source of internal heat, and that all of them have some kind of magnetic field, but the processes by which they are formed is different. So that concludes this lecture on the structures of the giant planets. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.